Okay, let us continue the Galerkian's approach. Okay, in the last video session we have derived up to this step. Okay, where the left part, that is integration of k into dw by dx dt by dx. Okay, let us find what is dw by dx and dt by dx of the left side term. Okay, in the dt by dx, where t is equal to n1 t1 plus n2 t2, by the isoparametric representation it can be written. We know that T is the temperature at any point within the element, and T1 and T2 are the nodal temperatures, and N1 and N2 are the shape functions. N1 and N2 are the shape functions. It is derived in the previous video, that is N1 equal to 1 minus x by L, N2 is x by L. Okay, so differentiating this dt by dx, differentiating this with respect to x, we have, okay, the differentiation of 1, it is 0, differentiation of minus x by L, it is minus 1 by L t1, differentiation of with respect to x, it is 1 by L t2, so it is t2 minus t1 by L. So let us consider, we know that n1 and n2 are the weighting functions. Okay, we know that n1 is equal to 1 minus x by L, n2 is x by L. So let us consider shape functions are the weighting functions. Weighting functions are the assumed displacement functions. Okay, n1 is equal to 1 minus x by L, that is w1. So dw by, differentiating this w1 with respect to x, that is minus 1 by L. Similarly, differentiation of this w2 with respect to x, it is 1 by L. Okay, so we have dw by dx. Now we have two terms, dw1 by dx, dw2 by dx. Okay, so the two terms can be written in terms of in the form of matrix. Okay, now we have dt by dx. Similarly, okay, let us substitute the known values here, dw1 by dx. Okay, here integration of k, we know dw1 by dx now, so dw1 by dx, dt by dx into dx. So k value as it is placed, dw1 by dx, that is minus 1 by L, dt by dx, it is differentiation of t term with respect to x, it is t2 minus t1 by L into dx. Okay, so minus k by L, t2 minus t1 by L, and it is integration of, okay, there is no dependent term, so integration of any value, it is L. Okay, applying the limits, it is L minus 0, so this one L and this L get cancelled, so it remains with minus k by L, t2 minus t1. Okay, now considering dw2 by dx, okay, we will get a minus k by L t1 plus k by L t2. Okay, you know, you need to substitute this value dw2 by dx. dw2 by dx, it is 1 by L, and d2 by dx, it is t2 minus t1 by L. Okay, again we have two terms. Okay, let us put all the both the dw1 and dw2 with respect to x in a single term. So it is, in the both terms we have k by L, it is common. Here also we have k by L, and in this also we have k by L. Okay, in all the terms you will get k by L. So you considering the first equation, what is the coefficient of t1 here? This minus plus, so coefficient it is 1. Coefficient of t2 it is minus 1. In the second equation, the coefficient of t1 it is minus 1, and coefficient of t2 it is 1. So k by L, 1 minus 1 minus 1 1. Okay, so t1 and t2. Okay, now we have got the left side term. Similarly, we will find what are the other two terms. Okay, integration of wq into dx. Okay, this we have derived now. Now we are deriving integration of wq over the dx length. Okay, again w, it is the weighting functions w1 and w2. Let us consider the w1. Putting w1 k dx, we are integrating with respect to dx over the limits 0 to L. Okay, W1 it is 1 minus x by L. Q it is constant, it is taken outside, and integrating with this value, integration of 1 it is x, and integration of x it is x square by 2. Already L is there. Okay, now you apply the limits 0 to L. Okay. Applying the limits, the upper limit it is L, lower limit is 0, so L minus 0 it is L. Okay, similarly you also apply here upper limit and lower limit, so it is minus L square by 2L. Okay, simplifying this we have QL by 2. Similarly you take the other weighting function, that is W2. W2 it is nothing but N2, that is x by L. Take the Q cons outside, integration of x by L, you apply the integrate it, that is x square by 2L, and apply the limits 0 to L, so it is again QL by 2. You get the same value here. So WQ by TX, as you have two values here, W1 and W2, so QL by 2 1 1. If you want you can take Q outside, so the inner word inside the matrix it is L by 2 L by 2. Okay, now we got one more term. Okay, this is derived now. Now let us find what is Wk dt by dx. Okay, the other term it is Wk dt by dx. We know the W values, we have two values, let us find with the W1. W1 k dt by dx. Okay, W1 it is 1 minus x by L, it is the shape function 1, and k is constant, and dt by dx it is differentiation of the isoparametric representation, that is t equal to n1 t1 plus n2 t2, where n1 is 1 minus x by L, n2 is x by L. Differentiating the t value, we have t2 minus t1 by L. Okay, now you apply the limits. It is not, integration is not required, as it is in the form of x. You apply the upper limit and lower limit. Upper limit, first you substitute upper limit minus the same terms with the lower limit value. So x value it is L minus the same value, but x value here it is 0. Okay, so L minus L it is 1, 1 minus 1 it is 0, 0 into any term it is 0, so the whole term it is 0. Here 1 minus 0 by L, 0 by L it is 0, so it is only k into t2 minus t1 by L, so minus is there, minus k by L t2 minus t1 minus k by L t2 minus t1 by L. Okay, similarly we need to consider other weighting function W2. Okay, x by L. Okay, applying the upper and lower limit, we have k t2 minus t1 by L. Okay, we have got the same values here, but with the one negative value and one positive value. Okay, this k t2 minus t1 by L, it is nothing but q naught. Okay, it is a Fourier law conduction, minus q naught, so it is plus q naught. So we have two terms, minus q naught and plus q naught. Okay, now we know all the three values. We know all the three values from this form. Okay, let us substitute all the three values. Okay, this value it is k by L 1 minus 1 minus 1 1 t1 t2, and the right side terms, that is ql by 2 L by 2, and the other term it is minus q naught plus ql. Okay, q naught it is Fourier law heat conduction at node 1, QL it is the same value at node 2 with the positive answer. Okay, substituting the left side term and right side terms. Okay, this is the important equation, and here it is the element conductivity matrix, and this is element heat rate vector. Okay. Okay, this is the Galerkian's approach of 1D heat conduction. Okay, thank you very much.